Hello, geometry. Here we go with lesson 7, pyramids and cones. So with pyramids and cones, we needed to find the slant height to find the surface area. Okay. With volume, we don't need the slant height. We need the altitude. Now, we sometimes use the altitude to help us find the slant height with surface area. So you've had experience with the altitude before, but this time we actually need that value to find the volume. Just a reminder, the altitude is the perpendicular segment from the vertex to the base. Okay. Most times, the altitude goes through the middle of the pyramid or the cone. Not always, and I will show you a couple examples where it doesn't, but most of the time it goes to the middle of the pyramid. Now, I posted a video in the extension column or the extra resources column on Canvas. If you're one that likes to know where these formulas come from and you can actually see it, that's what the video is for. If not, I'm going to summarize the video right now. The video starts with a pyramid and a prism with the same base and same height. So the area of the base is exactly the same. The height is exactly the same. It then shows that it takes 3 pyramids of water to fill the prism. So what you can conclude from that is that the volume of the pyramid is 1/3 the volume of the prism. So 1 pyramid filled up with water would only fill the prism 1/3 of the way. So that's where the formula for the volume of a pyramid comes from. Volume is the same as the volume of a prism, but there's a 1/3 in front. It's that easy, but it's also that easy to forget. So that's the trickiest part of pyramids and cones, is just remembering that 1/3. So I'm going to give you a suggestion as we do these examples here. So the base, again, we need to find the area of the base. It's a square. This is pretty easy. It's just 8 times 8. So the area of the base is 64. The height is the altitude. So the altitude here is 9. And so here's what I see a bunch of people do. They'll do 64 times 9 and write that answer on the line. Okay. When you see you're doing the volume of a cone or a sphere, cone or a pyramid, write out the formula. It's going to be the best way to remember that 1/3. So 64 times 9 divided by 3 is 192. And that would be cubic centimeters. All right, next one. Another pyramid. The base is a right triangle, so it's 1/2 base times height. So 1/2, that is perpendicular, so that's good. 8's the base, 14's the height, or vice versa. Doesn't really matter. So I just do 1/2 of 8, which is 4 times 14 is 56. So the area of the base is 56. The height, again, I gave it to you here, was 17. So now I just have to do 1/3 area of the base times the height. The area of the base, again, was 56. Height was 17. So 56 times 17 divided by 2. I don't get a good number, so I'm going to leave it as an improper fraction, which would be 952/3. And that would be units cubed. Okay. So pretty basic examples there where everything was given to you. There might be a time when you have to find the altitude, or you have to do some stuff to figure out the area of the base. You've seen that done. But there you go. Real quick, I'm going to write I'm going to scroll down first. This last question on the front here makes you think a little bit. We'll go back to number 1. We found 192 centimeters cubed was the volume of that pyramid. Now I'm telling you to imagine that we have a prism with an identical base as the pyramid in number 1. So we've got a square pyramid, or a square prism. Okay, so 8 8, but this one's going to be a cube. Or yeah, it's going to be a cube. Okay. What would the height have to be? So H, so that the volumes are equal. Well, in a prism, the volume is the area of the base times the height. Okay, so I know that I want the volume to equal 192. The area of the base is still pretty easy to figure out, 64. What would the height have to be? So 192 divided by 64 gives me 3. So the height would have to be 3 centimeters. Well, and I did that because I want you to see the height of the pyramid was 9. The height of the prism would have to be 3, 1/3 the distance, which should make sense if you look at the formula. Okay. All right, cones. Cones, just like cylinders, relation to prisms, cones are almost exactly like pyramids, except that instead of the base being a polygon, the base is a circle. Therefore, the formula for finding the volume of a cone is, don't forget the 1/3, area of the base is pi r squared times the height. That's it. So number 1, scroll down a little bit here. Number 1, we just need the radius and the height again. So the radius is 10, the height is 16. All right, so 1/3, don't forget that, pi, radius is 10. Sorry, not sure what's going on there. Times the height, which is 16. So that's 100 times 16. So that's 1600. So I got 1/3 pi times 1600. That does not divide nicely. So in terms of pi, it's 1600 pi divided by 3. And that would be centimeters cubed. Okay. Next one, you'll hopefully see that I did not give you the height. I gave you the slant height. This one would be pretty easy to find the lateral area and the surface area, but it's not as easy to find the volume on this one. I need to find that. Hopefully you understand that that's not too hard to do. So 9 plus h squared equals 49. H squared equals 40. And I'm going to say h equals 2 radical 10. Right, square root of both sides. Okay, so that's the height. So it's 1/3 pi. Radius I already knew was 3 squared times 2 radical 10. So 1/3 pi. 3 squared is 9 times 2 radical 10. 9 and 1/3 make 3 pi times 2 radical 10. So that would be 6 pi radical 10. And simplest radical form, meters squared. If I wanted to round that, I would go 6 pi times radical 10 and get 59.6 meters squared. Okay, so sometimes you do have to find the altitude or the height. Hopefully it's not too hard there. All right, this last part is just showing you the effect of a change. And so yeah, I'll do the first one. I gave you everything you needed. What is the volume of the cone with a radius of 4 feet and a height of 6 feet? So a cone would be 1/3 pi, radius would be 4 squared, and the height was 6. So 1/3 pi times 16 times 6. So 16 times 6 divided by 3, 32 pi. Now, everything I do from here on out is going to compare to this. All right, so I'm going to compare everything from 2 to 1, and then I'm going to compare 3 to 1, and 4 to 1, and so on. So let's look at what happens if the radius is doubled. So then my new radius would be, instead of 4, it would be 8. The height would be 6. Take a guess. What do you think is going to happen? Okay, now let's actually figure it out. So the 1/3 pi 8 squared times 6. So 8 squared is 64 times 6 divided by 3 gives me 128 pi. If you guessed that the volume would double because the radius was doubled, you see that that's not quite right. The volume was 32 pi. The new volume is 128 pi, which means the volume actually quadrupled, multiplied by 4. Okay. What is the volume if the height is doubled? So back to the original. So the radius is back to 4. Instead of 6, the height's going to be 12. What I'm hoping that you'll see is that the radius has a much bigger effect than the height does. So that's 16 times 12 divided by 3, 64 pi. When the height's doubled, the volume was doubled also. 32 pi to 64 pi just doubled. Okay, the radius has a bigger effect. What is the volume if the radius is cut in half? Well, instead of radius being 4, radius would be 2. Height is back to 6. So 1/3 pi 2 squared times the height. 6. So 4 times 6 is 24. A third of that would be 8 pi feet cubed. So if the volume originally was 32 pi and I cut the radius in half, the volume gets cut by 4, or divided by 4. See if you can predict the volume of the height is cut in half. So just make sure you understand what I'm saying. The radius is 4 and the height instead of 6 is 3. If you predicted that the height would be cut, or if the height is cut in half, that the volume would be cut in half, you would be correct. What happens if the radius is tripled? Then the volume would be 9 times greater. Seeing this relationship can be helpful. So not essential, but it can be helpful. We'll talk about this more when we start doing the homework. But that's it for volumes of pyramids and cones.